Okay, so today's hopefully a pretty easy lesson. We're just plotting points on a coordinate plane. We've been doing it a little in our skills review, so hopefully that's been pretty easy for you. So we're just gonna go over some quick vocab, making sure that you really internalize these vocab terms. All right, so we're gonna start here. We have our x-axis, right? It's our horizontal axis. And here we have our y-axis. And then in the center right here, where the x-axis and y-axis intersect, we have our origin. And that is 0, 0. So we have our coordinates. Right, these are all vocab words. And that is pretty much just x comma y. And let's do some examples. So we have point B is at -2, 3. Point P is at -3, -4. And point E is at 0, 5. So if we were to graph these, we'd have we go -2. So we always start with the x direction. -2, +3. 1, 2, 3, 1, 2, 3, 4, P. And then 0, 1, 2, 3, 4, 5, E. Right, so first we move in our x direction, then we move in our y direction. Okay, so a good question is what quadrant, right? So we have our point quadrant. And if you notice, our axes, right, our x and y axis, they create 4 sections. And these are called quadrants. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So quadrant 1 always has positive, positive. Quadrant 2 always has negative, positive. Quadrant 3 has negative, negative. And quadrant 4 has positive, negative. Right? So here we have a negative, positive. So this is in quadrant 2. Right? And we can see right here B is in 2. For P we have a negative, negative. So we know that it's in quadrant 3. And we can see right here P is in quadrant 3. And then E, even though there's no negatives, it's not in quadrant 1 because it's right here on the line. It's on the y-axis. So we're just going to put y-axis, right? Because it's not in quadrant 1 and it's not in quadrant 2. It's right in the middle. All right. So a very helpful skill is to be able to figure out points on a line. So you're going to want to be able to look at a graph and figure out what points are there. The trick is to find a point where your lines intersect, right? So if we look right here, we can see it's very clear that the lines intersect. But if we look here, for example, like if we try to go to 1, this is sort of in the middle, like it's in between 2 and 3. So we don't want to pick that. We want to pick the ones where it's very easy. So here, right, if we look here, we can see that this is intersecting really nicely. This is intersecting really nicely. Over here is intersecting really nicely, right? But if we were to look here, like this doesn't intersect nicely, or if we're trying to stay on this line, like this doesn't intersect nicely, you want it to be on the line. So once you practice, you might get a sense of that, but we want to be able to figure out our points. So let's start with this top one over here. We go -2 is our negative x, is our x, and then we go 1, 2, 3, 4, 5, 6, 7. Right? So we don't have any decimals or fractions, like we want whole numbers to find our points on the line, right? So let's put that there, right? We want whole numbers. Okay, so we have -2, 7, we have 0, 4, right here we have 2, 1, and right here we have 4, -2, right? And we can write this in like a table form. So we could do coordinate form, right? Coordinate, and then table, right? We have x, y, we have -2, 7, 0, 4, 2, 1, 4, -2. So you should be able to hop between these 3 pretty easily, right? Like I could say make a table from this line. I could say pick some coordinates. I could say make a table with the coordinates. Should be able to move pretty fluidly between these 3 things. All right, let's combine it now in an actual problem. So Sarah has 2 baseball cards. Each day she collects 3 more cards. So the initial value is going to be 2 cards. And our rate of change is going to be 3 cards per day. So if we were to turn that into a formula, we'd have our initial value plus 3 times x, where x is a day, right? We could say x equals days. Okay, so if we wanted to make a table, right, we have our x and our y. Our label for x is days. Well, that's our unit, right? So this is time, and the unit is days. And then this is cards, right? Y is the number of cards, and it's just count. Or like number, right? We could put like number. Okay, so if we were to fill this out, right, 0, at day 0 we have 2 cards, then another day we have another 3 cards. After 2 days we have another 3 cards, and then another 3 cards. So we notice, right, it's going up by 3, right? That's our rate of change right here. And then if we were to graph it, we could use these points here. So let's start with 0, 2, 1, 1, 2, 3, 4, 5, and then it just keeps going up. We don't know what happens in the past, right? Like the line could continue in the negative direction. Maybe, you know, yesterday she had 3 less cards, or she like owed someone a card. But we're just going to do like what we were given, so that's why we're going to have the line stop here at 0, 2. So again, you should be able to move between these 3 pretty easily, right? We have our equation, we have our table, and our graph. All right. This is a good question. So is the point 5,8 a solution to y equals negative 2x plus 3? So a lot of times I've noticed that some of you are not answering the question, right? So this is saying, is it a solution to this? So our answer should be yes or no. Right? I remember sometimes when we had the inequality unit, people were like saying the answer was inequality, but the answer was actually looking for like a yes or no. Okay, so the quickest way is to just plug in x and y and see, right? So if this is x and this is y, let's put in 8 equals negative 2, 5 plus 3, 8 equals negative 10 plus 3, 8 equals negative 7. That is not true, so we say no, it's not a solution, right? That doesn't make sense. 8 does not equal negative 7. But let's graph it, right? Let's take a look at what's happening. Okay, so if we plug in 0, right? 0 plus 3 would give us 3. If we plug in 1, 1 times negative 2 plus 1 is 1. Negative 1. And if you notice, our rate of change is negative 2. So, right, negative 2 rate of change. So each time this goes up by 1, this is going to go down by 2. So negative 3, negative 5, negative 7. Let's graph that. So we have 0, 1, 2, 3, 1, 1, 2, negative 1. Right, and we're going to graph this. Right, and so if we look at this line, let's look at 8, negative 7, right? So we have, or not 8, negative 7. Let's look at 5, 8. 1, 2, 3, 4, 5, 1, 2, 3, 4. So this is the point that it's asking us for, and this is the actual line, right? So clearly this is not a solution, right? So you didn't need to do all this to figure out the no, like we just did it algebraically here. But if you look at it graphically, it makes sense, right? This point is not on this line, which is why this is not a solution to that. All right, last part, fill in the table. So now we're doing what we did before, right? We're looking at these points and we're filling in a table. So very similar, but this time I gave you the points specifically rather than you trying to pick the points, right? So we have negative 3. 1, 2, 3, 1, 2, 3, 4, negative 4, negative 2, negative 2, negative 1, 0, 0, 2, 1, 4, 2, 6, right? So Our rate of change is 2. We can see the slope is positive. We'll get into that more later. Right now, we're just thinking about plotting points and getting familiar, moving between the graph and the table, and doing some algebraic solutions. So hopefully an easy lesson. Make sure you do the practice problems and you double check your answers.